What's up, psychology scholars? Today we're going to go over the stats portion of the Scientific Foundations of Psychology unit. And the reason that you need to know about statistics for AP Psychology is because when psychology researchers do studies, they collect data that they will have to plot and analyze. And this is something that the College Board wants you to be able to do as AP Psych students. So today we're going to look at something called frequency distribution, which just means that we're talking about plotting how often certain phenomena occur. Let's dive in. Okay, so for this first example, we're going to pretend that you're a PE teacher. And let's say that you just finished up a unit on basketball. And for the final exam for this unit, you ask your students to take 20 foul shots. So after the students take their 20 foul shots, what you're going to do is you're going to collect the data and plot how frequently the values show up. For example, let's say that one of your students hit 7 out of 20 foul shots, 3 students hit 8 out of 20 foul shots, 5 students hit 9 foul shots, 7 students hit 10 foul shots, and so on and so forth. So by the time you collect the scores from all your students and plot them out, this is what the data set looks like. And by pure chance, you get this nice symmetrical distribution. So the next thing that you can do is plot a curve of best fit. And this is what that would look like. Now, if you were to calculate the mean, median, and mode for this data set, you would find that they would all line up around the center here. Remember, the mean is the average, the median is the middle number, and the mode is the value that occurs the most often. And what we have here is something called a normal distribution. And a normal distribution is an arrangement of data values that clusters around the middle where the mean is located. And the values further away from the mean taper off equally on both sides, giving us this bell-shaped curve. So this is called either a normal distribution or a bell curve because it looks like a bell. Now, let's say that you teach another PE class, and in this PE class, you have the varsity basketball team. And these varsity basketball players are crushing it when it comes to hitting their foul shots. You know, they're hitting 16, 17, 18, 19, 20 foul shots. They're doing really well. Let's also say that you have 2 students in that class who don't play any sports at all. Let's say that one student only hits 1 out of 20 foul shots, and another student hits 3 out of 20 foul shots. And because of this, you get a curve that is shaped as such. And the reason your graph is shaped this way is because you have the bulk of your data up here, and you have these things over here called outliers that skew the data, which, as you can see, pull the mean way over, unlike on a normal curve where the mean, median, and mode are all the same. And therefore, as you can see, this is called a negatively skewed graph. And the reason it's called a negative skew is because the tail of the curve points towards 0 and points towards negative numbers. Now you can see on a skew graph that the mean, median, and mode do not line up all nice and neatly like they do on a normal distribution. You can see that the mode is always going to be the highest point in the curve. The mean is going to get pulled way out here due to the outliers, and the median will tend to fall somewhere between the two. Now, when it comes to analyzing data in a normal distribution, researchers tend to look at the mean as their go-to measure of central tendency. But when it comes to looking at a skewed graph, the median is the most useful measure of central tendency due to the mean being so dramatically impacted by the outliers. So let's use the PE analogy one more time. So let's say that you teach another class, and in this class you have students who have never played basketball before, and you also have 2 students who are really good at basketball. We'll call them LeBron and Steph. Well, as you can see here, LeBron hit about 18 out of 20 foul shots, and Steph hit 20 out of 20 foul shots. But the bulk of the scores fall down here on the low end, so this makes this a positively skewed graph. And the reason that this is a positively skewed graph is because the tail is pointing towards increasing numbers, unlike a negatively skewed graph where the tail is pointing towards 0 and negative numbers. And again, it's skewed due to these outliers over here, and these outliers pull the mean way over in this direction. The mode is always going to be the tallest part of the graph, and the median will always fall between the two. And as I said before, when looking at a skew graph, the go-to measure of central tendency that you want to use is the median, because the mean or the average gets pulled way too far out due to the outliers. So next up, we're going to look at something called standard deviation. And standard deviation, as it says here, is a measure of spread, which tells us how close the values in a data set are to the mean. So let's take a look at this red curve here. So this red curve tells us that the values are really squished up against the mean, telling us that the deviation is small. So this is a small standard deviation. On the other hand, this blue curve, you can tell that the values are way more spread out, depicting a large deviation. So now let's take what we've learned about standard deviation and apply it to a practice problem. Here we go. Which of the following data sets has the greatest standard deviation? Now, there is a way to calculate standard deviation, which you can learn in stats or math class, but to do so would take absolutely way too long for this AP Psych test. So there's a shortcut that will help you find the right answer. And the trick is to look at the range. Now, this question wants us to look at which data set has the greatest standard deviation. So what we're going to do is we're going to find the data set with the greatest or largest range. So go ahead and take a second and calculate the range for A, B, and C. Okay, you should have figured out that the range for A is 13, the range for B is 24, and that the range for C is 3. And that would mean that the right answer to this question is B. B has the greatest range, and therefore B has the greatest standard deviation. And if you use this trick of looking at the range, you should be able to end up with the right answer the majority of the time. And by the way, when this question is asking about which of these data sets has the greatest standard deviation, what it's actually asking is which of those data sets would look more like the blue curve here, where the data is more spread apart than the red curve. Now, let me point out something real quick. You may get a question that asks which of these data sets has the smallest standard deviation, and in that case, you would look for the data set that has the smallest range. And for us right here, the answer to that would be C, because it has a range of 3, which is smaller than the other two ranges. Okay, next up, we're going to talk about z-scores, which measure the distance of a score from the mean or average in units of standard deviation. Let me show you what this looks like. For AP psychology purposes, z-scores will always look as such. And we're going to start right here in the middle because that's where the mean is, that's where the average is, with a z-score of 0. And then we're going to move to the left one line, or we're going to move to the left 1 unit of standard deviation, and that's going to give us a z-score of -1. So let's move to the left 1 more unit of standard deviation. This is going to be a z-score of -2 and a z-score of -3. Now let's come back to 0 in the middle, and we're going to move over right 1 unit of standard deviation for a z-score of +1, move over 1 more unit of standard deviation for a z-score of +2, and so on and so forth. As I mentioned, z-scores will always look like this: -3, -2, -1, 0, 1, 2, 3. Now that you can see how z-scores are plotted, let me show you how to actually use them. So let's say that there's an AP Psych test question that says something along the lines of, Miss Smith has a class that took a test and the average score for that test was 80. And the given standard deviation for that test is 8. Now, how can we take this data and apply it to this graph? So what we're going to do first is we're going to look at the mean. And we know that in a normal curve or in a normal distribution, the mean is always in the middle. So what we're going to do is we're going to plot the mean of 80 under the z-score of 0. Now, the given standard deviation in this question is 8. So what we're going to do is we're going to start with the mean of 80, and we're going to move 1 standard deviation to the left by subtracting 8 from 80. So 80 minus 8 is 72. And then we're going to move over to a z-score of -2 by subtracting 8 again. So 72 minus 8 is 64. And then we're going to move over another unit of standard deviation by subtracting 8 again. So 64 minus 8 is 56. So now let's come back to the middle, and we're going to move to the right 1 unit of standard deviation. So 80 plus a standard deviation of 8 is 88. We're then going to add 8 more to 88 for 96. And then we're going to move 1 last unit of standard deviation to the right. So 96 plus the standard deviation of 8 is 104. So now that we have this data plotted, the test question may go on to say something like this. A student named Sarah is in this class and her test score is 96. What is Sarah's z-score? Well, you can see that the score of 96 lines up with a z-score of +2. Or you might get a question that says, Billy's z-score is -2. What is Billy's test score? Well, his test score would be 64. Or in a trickier example, you might get something like Bob's test score is 92. What is Bob's z-score? Well, you can see that 92 falls between 88 and 96. So Bob's z-score would be 1.5 because it falls directly between these two numbers. And in AP Psych class, that's as tricky as it'll probably get. Okay, so here's another given set of numbers. In this case, the mean is 45 and the standard deviation is 7. So what I want you to do is go ahead and plot out these numbers on your own. And remember, you're always going to start in the middle with the mean. And in this case, the mean is 45. So you're going to plot that right below the z-score of 0. Okay, so pause this video real quick and knock out the rest of the numbers. Okay, so this is what you should have gotten. You're going to add 7 each time you move a z-score to the right, and you're going to subtract 7 each time you move a z-score to the left. So something that you should understand when we calculate standard deviation is we generally find that 68% of the data values are within one standard deviation of the mean. In other words, 68% of the values fall between a z-score of -1 and +1. Continuing on, we tend to find that 95% of the data falls within 2 standard deviations, or between a z-score of -2 and +2. And you should also know that 99.7% of the values fall within 3 standard deviations, or between the z-scores of -3 and +3. And unfortunately, these percentages are just something that you're going to have to memorize because the College Board may ask you questions about them. Okay, so the last thing that we're going to look at today are percentiles, which indicate the percentage of scores that fall below a particular score. And this may sound confusing at first, but let me give you some examples. The first example deals with my son, and when my son was a year old, he was in the 90th percentile for head size. This meant that his head was bigger than or equal to 90% of the boys his age, which is pretty big. Now, another place you may have seen percentiles before is when you get the results of your PSAT or your SAT back. Oftentimes, it'll say something like, you are in the 66th percentile for this test. This means that you've done better than or equal to 66% of the test takers, and that 34% of the test takers did better than you. So what I'm about to show you are the percentiles that line up with each z-score. So the percentile that lines up with a z-score of -3 is the 0.13 percentile. So if someone is in the 0.13 percentile, that means that they've done better than 0.13% of test takers. The percentile that lines up with a z-score of -2 is the 2.28 percentile. -1 is the 15.87th percentile. A z-score of 0 is the 50th percentile. +1 is the 84.13 percentile, +2 is the 97.72 percentile, and +3 is the 99.87 percentile. And these are unfortunately something that you're just going to have to memorize for AP Psychology. And this all may look confusing at first, but let me show you how to use this information. Let's say that using the data from earlier, Luke scores a 66 on the test. And then the question asks, what is his percentile score? Well, what you need to do is take this 66 and understand what his z-score would be, and then from there, use the z-score to figure out his percentile. So since his z-score is +3, Luke would be in the 99.87th percentile, meaning that he did better than or equal to 99.87% of the test takers. Or you might have to manipulate the information the other way. So let's say that Laura is in the 15.87th percentile. Using the data from earlier, what is her test score? So you can see that 15.87 lines up with a z-score of -1, and using the data from earlier, that lines up with a test score of 38. So you need to know how to manipulate this information back and forth. Okay, let me show you one more thing. Let's say that Levi is in the 84.13 percentile, and the test question asks, what percentage of students did better than Levi? Well, what you're going to do is you're going to subtract 84.13 from 100%. So 100% of the test takers minus 84.13% will give you an answer of 15.87% of the test takers did better than Levi on the test. And that's pretty much it. That's a crash course on AP Psychology statistics and frequency distribution. And if you learned anything new today, make sure you check out my TikTok account, which has a bunch of different videos like this one, which you won't be able to find on my YouTube channel. Catch you later, All-Stars.